going to talk about is this. The limit of b as x approaches c. So these are rules, so they're going to have a lot of letters in them because they're just general formulas. B represents some constant and C represents some constant. So this could be like, for an example, the limit of 7 as x approaches 3. That's what this question might look like if I gave this to you. Now, the function that we're finding the limit of is 7. What's the function of 7 look like on the graph? That's y equals 7. What's that look like? A horizontal line at y equals 7. Okay, now think about this. As x is approaching 3, what y value is that graph getting closer to? 7. No matter what x is approaching, that line always has a y value of 7. So my answer is 7. So this formula is going to say b. So if you ever have the limit of a constant, the answer is that constant. Those are the ones you hope I put a lot of on your homework and your tests, because those are the easy ones. The limit of 5 as x approaches 20. 5. The limit of 102.7 as x approaches 1. 102.7. So that's what that first shortcut is. The second shortcut is the limit of x as x approaches c. So it's the function y equals x. You can picture that in your head. That's that diagonal line. That is going to equal whatever c is. So it's like you're kind of substituting that in. So as a problem, I might say the limit of x as x approaches 4. And your answer is going to be 4. So that's another really good one. Really easy and simple. And then the third shortcut, the limit of x to the n power. So it could be x squared, x cubed, x to the 7th power. As x approaches c, you're just going to replace again. So it's going to be c to the nth power. And so that might look like this. The limit of x to the 8th power as x approaches 3. And then you replace that x with a 3, and you've got 3 to the 8th power, and we're just going to leave it like that. That's our answer. If you want to figure it out, I'm not going to stop you, but you can leave it as 3 to the 8th power. So those are going to be nice and easy. You don't have to show any work on those. You just use those as shortcuts when we're finding limits. Next, we're going to talk about 5 different properties that are going to help us out along the way. The first property is called the scalar property. And you used this word before. You might have talked about it as a coefficient, a number out in the front, scalar. And here's what the property says. The limit of b times the function as x approaches c is the first part. So that's b stands for a constant, so it's going to be some constant times a function. So maybe it's 4 times the cosine of x, or 7 times the natural log of x. There's a scalar out in front of your function. What you can do is you can bring that scalar out to the front and then do your limit. So you can worry about your scalar at the very end. Figure out your limit first, then multiply by the scalar. So let me give you an example problem. Let's say we have the limit of 4x as x approaches 2. What's the scalar in that problem? 4. So what we can do is we can bring 4 out to the front, and have this problem. Is that limit one of our shortcuts? Yeah, that's shortcut number 2. So we just replace it. So it's 4 times 2. So the answer is 8. So that's what we can do with the scalar property. It becomes to be really helpful when we get into trig and natural logs more. Okay, the second property is going to be the sum or difference property. Okay, what this says is we could be taking the limit as x approaches c of f of x plus or minus g of x. So you've got two functions that you're adding or subtracting together that we want to find the limit. So it could be x squared plus 7x. It could be the sine of x plus the cosine of x. It could be 2 minus x, anything you're adding or subtracting. What this property tells us is we can take a look at each of them separately. So we can do the limit of f of x plus or minus the limit of g of x. So you can take the limit of each one and then add them together at the end. Okay, let me give you an example. Let's do the limit of 2 plus x squared as x approaches 3. What I can do is I can split that, because they're being added, into the limit of 2 plus the limit of x squared. And those are both as x approaches 3. Now, is this first part one of our shortcuts? Yeah, that's shortcut number 1. What's the answer to that limit? 2 plus, is that second part a shortcut? Yeah, that's your third shortcut. What's the answer going to be for that? 9, because you put a 3 in there. So that is 11. So your goal is use these properties to break them down into what looks like our shortcuts. Okay, then the third property is product. And this tells us if we take the limit of f of x times g of x, so two functions being multiplied together as x approaches c. There's been a theme so far. We've kind of been splitting it up. We can split it up to the limit of g of x. Whoops, sorry. I should start with f of x to stay in the pattern. Times the limit of g of x. Okay, and this would be something that we could say we could use this property for. You got two functions being multiplied together, 7x and x squared. We can split it to the limit of 7x times the limit of x squared. That 7x is also a scalar. What's the scalar of 7x? 7. So you can bring the 7 to the front. And then what's the limit of x as x approaches 1? 1 times, what's the limit of x squared as x approaches 1? 1. Plug that 1 in. And then our overall limit is going to be 7. Alright, fourth property is going to be the quotient property. And this says if we take the limit of f of x divided by g of x, any ideas what we can do with that one? What the property is going to say? Split up the limit of f of x divided by the limit of g of x. And they're both as x approaches c as well. Alright, let me give you an example of this. The limit of 14 divided by x cubed as x approaches 2. Limit of 14 over x cubed as x approaches 2 can be the same limit of x cubed. And they're both as x approaches 2. What's going to be the limit of 14? 14. What's the limit of x cubed as x approaches 2? 8. And so there's our limit. You can reduce that if you want, but you can leave it as 14/8. Okay, then one more property, and this is going to be the power property. And this says that if we take the limit of a function to some power as x approaches c, we can take the limit of just that function and then apply the power at the very end if we do order of operations with that. Okay, so let's practice with this one. The limit of x plus 1 squared as x approaches 5. What we can do is we can just worry about the limit of x plus 1 first and then square the very end. Inside of that, we can separate it to the limit of x plus the limit of 1 if we use the sum or difference property. This is all as x is approaching 5. What's the limit of x as x approaches 5? 5. What's the limit of 1? And then we're going to square that final answer. So there's how we do that limit. Now, these are going to become second nature. You won't have to think through, you won't have to write as much as we get better at this. But right now, when we're in the baby stages, we're gonna take our time on these, and then we'll get faster at them. Is there anything, before we try one bigger problem with these, is there anything about those properties you want to ask about now? Alright, let's try one big function with this. Let's take the limit as x approaches 3 of 16x cubed plus 5x squared. And we're going to have to use different properties and shortcuts to solve this one. And at the beginning, I want to see all of your work on these, even if you can do some of it in your head. Show me the property. What do you think we should do first for a property? Split it up. Do the sum or difference property. And just because I'm going to be lazy, I'm not going to copy this x minus 3 throughout the whole thing. X approaching 3. Okay, what's another property we could use? Scalar. Which one has a scalar? They both do. And then what can I do? What, is there anything else I need to do with the limit part? Or is that in shortcut form? That's the third shortcut, right? X to a power. So this is x approaching 3. Okay, so we've got 16 times, like a 3 in there. 3 to the third power. Plus 5 times 3 to the second power. 9. No, I don't know that in my head. Anybody got a calculator real quick? Thank you. Plus 45. 177 is our limit. Oh. There we go. And that's how we're going to do those limits. Okay, what I'm going to do is I'm going to give us a worksheet to work on. We're going to just take a little break from notes and try this out with these properties. Okay, when you see this, the directions say use limit theorems 1.1, 1.2, and 1.4. That's those shortcuts and properties. That's all it is, just with a limit number, a theorem number. Try number 2. So write out number 2. We're going to skip number 1 for right now. And use all the properties and shortcuts you can to figure out the limit to number 2. Will, what would you do first? Good. So what's that look like? Read it off to me. Good. Good first step. Luke, what would you do next? Okay, yeah, but then bring the coefficient out to the front, so we'll do a scalar property. Okay, read us what that looks like.
Q limit of x squared plus full limit of x plus.
Yeah, we can just, since there's no other value, let's leave it there. Alright, Parker, what can we do next? Yes, the shortcuts. So we're approaching -3, so -3 squared is negative or positive? Squared. Yeah. And then Andrea, limit of x as x approaches negative 3. Yeah, right here. With that. Okay, so we've got this, and then for Luke's step, he said we're going to use our scalar, so we bring the 4 out, and then the limit of x, this is our second shortcut, where it's the limit of x, so you plug in what x is approaching, so you plug in a negative 3 for x. Does that make sense? Okay. Let's see here. Emily, what's the limit of 1? 1. Good. And then we go through and we simplify, and we get 7. All right, let's try number 3. It does matter what order you do the properties, so be careful on order. All right, Elizabeth, what should we do first? With brackets? Okay. Good. Okay, so that is using the power property and the sum or difference property. So you bring the power out to the whole thing, and then take the limit of each of them separately. All right, Cole, what should we do next? Yeah, you can do the shortcuts now. So as x approaches negative 4, what's that limit? And what about the second one? And we take that value and square it. So our limit is a 1. All right, we are ready for the square root one next. Try that one out. What's the square root also? 1/2 power. All right, Brandon, what's the first thing we should do? Okay, so again, very similar to the last one. You do your power property and your sum or difference property, and then Sadie, what can we do after this? Yep. X approaches 3 was the limit of 1, and then add 3 and 1, you get, what's 4 to the 1/2 power? 2. So that's the answer. Okay, now take a look at the last 3 that we did on this paper, 2, 3, and 4. Do you see any connection, something we could do, any shortcuts on the overall process? Yeah, without all the properties, that's technically what we're doing. But what if you would have taken let's go to number 3, and just right here, what if you would have plugged a -4 in? -4 plus 3 is -1. -1 squared is 1. Now, most of the time, I'm going to let you go fast, but when we're first starting out, I might make you write out all the properties so you know mathematically where they're coming from. So if you see anything like use the limit theorems or use your shortcuts and properties, we're going to do what you just did on your paper. Other than that, we just learned the easiest way to find a limit, and it's called the substitution method. You take what x is approaching, and you plug that into the function, and if you get a number, that's your limit. And so that is the first analytical method. So last week we did graphical and numerical, and today we're starting analytically. Your easiest analytical method, just try substituting it in, and that can give you a limit. Now we're going to come up with issues. There won't be problems with that, and we'll talk about that tomorrow. But that's my go-to method. When I solve a limit, I try substitution out for the very first thing, and hopefully it works. And that's what we're going to be doing. Okay, now to end off this part of the lesson, I know your favorite thing to do is trig, so we're going to talk about some trig theorems. I just couldn't end the day without giving you a bright spot. Okay, there are going to be 2 trig theorems for limits, and the way they got them is a very, very long proof. If you're interested in that proof, check out your textbook, but I'm not going to go through that proof with you. So what I need you to do is when I write these down, I'm just going to have, there's just something you're going to have to memorize. Okay, here's the first one. If we take the limit of the sine of x over x as x approaches 0, that's always going to be 1. Limit of sine of x over x as x approaches 0 is going to equal 1. And then the second one is the limit as x approaches 0 of 1 minus the cosine of x over x equals 0. So those are the 2 trig theorems that we're going to need to memorize. Now, sometimes they might just pop up like this. I might put on the test this question, and you would need to know it equals 1. But other times, you're going to see it in a different form, and all that stuff you learned in pre-calculus will have to come back. And this is one of those times we're going to practice. Let's say you had a problem like this. Well, the 2 trig theorems, one has a sine, one has a cosine, neither one of them have a tangent in them. So you know last year how you had to get equivalent expressions, and we did that trig magic square, you had to get things changed into different forms. It's because we have to solve different things like this. So what's an easy equivalent expression for tangent? Sine over cosine. And I think one of the tips that Mr. Fireball gave you last year is if you can get it into terms of sine or cosine, it's usually easier to work with. So we're going to rewrite this in terms of sine and cosine. So the tangent, I'm going to put sine of x over cosine of x divided by x. Okay, and then you learned back in algebra, dividing by something is the same as multiplying by its reciprocal. So I'm going to rewrite it. Sine of x over cosine of x times 1 over x. Okay, now this is going to be another algebra property. What's 3 times 5? What's 5 times 3? Does it matter what order you multiply? No, that's one of your properties from algebra. You can do 2 times 1 or 1 times 2. It doesn't matter the order. So when we're multiplying, it doesn't matter the order. So watch this little swift maneuver. What changed? I switched places of the x and the cosine x. They're being multiplied together. Doesn't matter if I switch the order. Okay, now do I have something that looks like one of those trig theorems? Part of it is, yes, sine of x over x. That's great. So what I'm going to do is I'm going to use the product property and split these up. And then this is one of our trig theorems. What does that equal, that first part? 1 times, okay, now the second part isn't one of our trig theorems. But do you remember what I just told you the easiest analytical method is? Plug it in. So let's put a 0 in here. Do you remember cosine of 0? 1. What's 1 divided by 1? That's our limit. So, you know all that trig stuff you thought was useless last year? You gotta remember it this year. Don't stop glaring at me, Cole. Okay, I've got another one for you. Limit of the sine of 4x over x as x approaches 0. What do I wish wasn't in there? The 4. 4 is messing it up. Now here's what you can't do. You can't just bring that 4 out to the front. That's not how it works, because it's the sine of that. You can't just bring a scalar out of a sine function. We can't do it. But we can do this. What if I multiply by 4 over 4? What's 4 over 4 simplify to? So if I multiply by 1, I'm not changing the value. So I'm going to multiply by 4 over 4. And you think, wow, you're just making this more complicated. But here's the deal. That trig theorem that we have from way back when, 2 minutes ago, here's a special case. All you need to do is have this x match this x. It doesn't have to be an x. If this is 2x, this has to be 2x. If this is 7x, this has to be 7x. So let me look at this now. This is 4x, this is 4x. So I can use that property. This is going to be a match for that property. What can I do with this 4? That's a scalar I can bring to the front. So then I've got 4 times, and then if these parts match, it's like that theorem, so it's going to be a 1. So my answer is 4. Now you say, that 4 was just in the beginning of the problem anyways. Yeah, but mathematically, how do we do it? And this is how you do that. This is how I like to think of that theorem. It's the limit, as x approaches 0, of the sine of smiley face over smiley face equals 1. Because as long as these two match, it doesn't matter what that is. So it doesn't just have to be an x in those spots. It could be natural log of x, natural log of x. As long as those two parts match, you can use this theorem. Alright, I'm going to stop torturing you for today. I'm going to give you an